All right, happy Thursday. How's everyone doing? Have you ever seen a more adorable baby? I mean, I'm a little bit biased, but it's awfully cute in my household these days. So we have a good one today. We're talking about numerical variables. So we're going to go through and try to summarize a couple of numerical variables using two different approaches. So one thing we need to do when we're thinking about our variables is try to summarize them. This is like the big part of what we're doing at the beginning of the semester. And we've spent some time talking about categorical variables last class. So we got our hands on some data and worked on some summarization techniques, both in Excel and in Python. And I showed you the approaches we take to summarizing in Python are nearly identical to those in Excel, except they're generally much simpler. You can make things very complicated in Python, but when it comes down to it, most things can be done very simply. And so we walked through a bit of an example last time. You remember we talked about these different coffee shops. We thought about different choices for summarizing categorical variables. And it turned out your preferences about which visualization was simplest to read, depended a bit on the question and the data type. So we looked at categorical variables. When we did nominal categorical variables like this, where we have an unordered set of categories, and we had more than two unordered categories, we generally thought box plots were the best approach, at least for most use cases. We said, pie charts are fine in some cases. The standard advice is to never use them, but we talked about one example of when using a pie chart can be actually useful. But in general, bar charts are going to be the one that you use with categorical variables. And so we walked through a bit of an example of how we do this. We did not do the binary categorical variable that we talked about in the slides. For the sake of time, we're not going to do this in class. But you can take a look at the slides and try to walk through some of the work we do there. So I've included, we spent a little bit of time on dataset 1 with the coffee shops. There are 3 other datasets that you can work with. And I have the visualizations in the slides for you to continue working with. But we're not going to spend class time walking through these exercises. These are great if you want a little bit of extra practice on your own. So this was the main thing we did in Python, which I've given you the code here to make the summary table and then to make the box plot. Seaborn makes this very easy for us. We just plug in the data set, shops, and then we tell it on the y-axis, we plot the state, and then we can color it by state as well. So we have different colors, and we just organize it this way. And then I've also included some code to make a binary categorical variable. I told you that Seaborn does not have a built-in pie chart, but what we can do is create a binary categorical variable from the categorical variable, the ordinal categorical variable, and then create a count plot, just as we did before. So here's some code to be able to do this on your own. And then the last thing was to create a pie chart, and I've just given you a little bit of code here to make it. I'm not emphasizing this because this is not something we do a lot of, but this could be good extra practice for you if you want to become more familiar with some of these tools. And just as a reminder, in addition to these exercises, there's also homework. So homework 1.1 and 1.2 are available on Gradescope. A couple of common questions about these. You can complete them either in Python or in Excel. So I'm going to show you how to extract figures in an image format from both Python and Excel. So we're going to do both of these things. At this stage in the class, I don't care which tool you're using, and you can use either one for any of these assignments, so feel free to pick the one that you prefer. This is a good chance to get more familiar with Python. It's the tool we're going to use in the second half of the class almost exclusively. So now's a good chance to spend a little bit more time working in Python. But if you just want to answer these first couple of homeworks in Excel just to get started, you're more than welcome to do it that way. Okay, and then there were three other data sets that you can find. I've given you the notebook to work with these. So yeah, feel free to get started, or use these as extra practice. This last one is just we have an order to it, and so you can work with the order. But we're not going to spend a ton of time on that. And then I give you sort of example visualizations in the slides. All right. Aren't these nice figures? I love looking at good figures. I love talking about good figures. Should we do some more of that? Yes, let's go. You're ready to talk about numerical variables? A lot of what we talk about in economics, a big focus of this class, especially in the later portion, will be on numerical variables. We're going to do a bunch with categorical variables, but we're going to spend a lot of time talking about numerical variables. And the place to start, step one, whenever you encounter a new data set, once you've classified the variable types, then you try to summarize the most important variables in your data set. So we've talked about categorical variables. I'm going to show you some nice pictures, and we're going to try to use tools to understand our data sets. So eventually, we're going to end up working with some Starbucks data. So you can download the Starbucks profile data if you like. This is a powerful data set. And I've given you the link for the source here, so you can actually download it from this data website, Kaggle. So you can click on this and take a look at where I got the data set from. But you can see we have customer profiles for lots of Starbucks users. How many of you have gone to Starbucks in the last 48 hours? Some people in the last hour. Yeah, I went to Starbucks this morning. I got a coffee. Nothing fancy, but I'm in their data set somewhere. Not this one specifically, but in one of the data sets. Starbucks collects lots of information about their customers. And as we're going to see in the next couple of weeks, as we work with Starbucks data, they actually can use this data very effectively for lots of different purposes. So it's very useful for a company like Starbucks to know something about who's buying their coffee and some characteristics about promotional offers and income. There's lots that Starbucks knows about us. So this is just a data set. There's gender, age, there's this ID variable, there's became a member on, and then there's some information about income, which I find a little bit creepy. But these are the kinds of things that Starbucks has on offer. So we're going to work with this data set. You can download it directly in its raw form from the link I gave you. But you can also just download the data set that I've given right here. So I've cleaned it up a little bit, but you can access the original source here. Okay, and then we're going to work with this notebook eventually. But for now, let's just think about some nice visualization. So as always, we're going to sort of talk through some things, and then we'll get into the exercise a little bit later. All right. So as always, we're thinking about summarizing the variables that we have on hand appropriately, which is the main set of questions in your homework. So if I were to give you this figure, I've taken the Starbucks customer profile data, and I've created what we call a histogram. This is just, bins. We have everyone's ages, and I'm just putting each individual customer in one of these bins. You've probably seen a figure like this before. If I were to ask you this question, what would be your answer? So which age group has the most Starbucks customers? Yeah. So 55 to 64, yeah. We can tell it's the largest group because the count is the highest. Each one of these bins is just counting up the number of customers in the age bracket on the horizontal axis. But you've noticed something maybe already as I give you the hint on screen. There's something pretty misleading about this figure. And that's the bin sizes are not equal. So remind me of your name? So Luke is saying, look, we have 55 to 64 being the largest. Oh, this is a mistake on the slides. Okay, my punchline is totally taken away. So the bin sizes actually are equal up until 75. So this is a little misleading. I should say it's not misleading. I'm going to have to fix that. So the figure should have been a figure looking a little bit more like this. So my punchline is, wow, this is a great way to start class. Who made these slides? I'm going to blame it on my daughter. Wow, that's a little bit rude. So the figure originally was going to look like this. So we would have equal size looking bins on the horizontal axis, but the actual intervals were going to be different widths. And then I was going to show you this figure to actually show you what the horizontal axis bins would be if we were actually correctly showing the widths. This is a misleading figure, right? Like if we were to show each one of these bins with the same width, some of these bins are much wider. So this interval here would show, a collection of customers from a wider age group. And then this upper age group is much larger. When bin sizes aren't equal like this, it makes it really difficult to answer this kind of question. So Luke actually answered the question correctly and did it very nicely. We have the largest group, according to this figure, with equal size bins is 55 to 64. This is the way we want to set up our figures so that it's easy for your audience to understand. 55 to 64 is the largest group. But if we were to use different size bins, it would be a little bit misleading. Okay, so we've, with this figure, I guess one thing that's maybe a little bit misleading about this figure is 75 is a very large group. And so one thing we can do is spread that out. We know customers in age go up much larger than 75. So we could actually break that out and make a graph that looks a little bit nicer. Okay, so terrible punchline to a great set of slides. But we have other considerations as well. So this picture makes it really easy to see that this age group, around 60, has the largest customer base. But we could also ask more nuanced questions of our data. For example, do 55-year-olds and 60-year-olds have different consumption patterns? Like this question. If we want to distinguish between these two different age groups, this data set, or this visualization, is not very good at answering that question, right? The bin covers both 55 and 60-year-olds. So this bin does not distinguish between those two subgroups. Anyone know what we could do here? If we were interested in distinguishing between these groups, what might we do? Yeah. Yeah, remind me of your name? Jake. So Jake is saying, let's just make the bins smaller. So what a histogram is doing is just counting the number of ages, or the number of observations that fall in the bin, and then just counting them and creating a bar chart for each one of these bins. So one thing we could do, as Jake is recommending, is just make narrower bins. So if you want more precision in your figure, if you want to communicate more detail in the distribution, one thing you can do is create narrower bins. So what I've done here is create bins of 5 years, where before I had bins of 10 years. So this would, allow us to answer the question we had before. You can see the 60-year-olds don't buy quite as much as the 55 to 60-year-olds. So we have these two bins, and you can now distinguish between these subgroups. What if we wanted to take this further? Let's say I want to look at the difference between 44-year-olds and 45-year-olds. How many of you think we could take this down to 1-year intervals? Hands for yes? Hands for no? Okay, the answer is yes, we can do it. I'm going to show you what that figure looks like. What if we want to distinguish between the coffee consumption at Starbucks of 44-year-olds and 45-year-olds? And it looks like this. So this is a figure where we have each individual year, no age groups, just individual ages across the Starbucks customers, going from, I think it's 18 all the way up to 115. And here we can clearly tell 55-year-olds buy more coffee at Starbucks than 44-year-olds. Do you think this is a real pattern? Like, someone tell me, what's going on here? Why does it look like 44 is maybe a third of 45? Yeah, is it ends with a K, doesn't it?
It has a K in it.
Okay.
It's okay, you're good.
Luke?
Is it because we don't have enough observations for it to be a normal curve?
Yeah. First, remind me of your name.
Luke.
Luke.
We got two Luke's and Lucas.
Yeah, that's right.
That's stuff. It's okay.
Yeah, my memory is finite. So we have very narrow bins, which means as we take each individual customer and place them in a bin, we don't get a lot of observations for each one of these bins. And just due to chance, we get a lot of variation between the different bins. So because we don't have a lot of observations in each bin, there's a lot of what we call noise. that's contributing to the sort of spikiness of our histogram. And we didn't see this actually when we had wider bins. When we have wider bins, we have more observations falling into each one of the bins, which kind of smooths out this spikiness. So one thing we can do is reduce the spikiness by placing more observations in each one of the bins. And we can do this generally in two ways. Anyone have an idea for how we do this? I mean, one we've already sort of talked about. So maybe the first one is a little bit simple. There are two ways of doing this. Gonna leave me hanging like this? Oh, yes. So yeah, so we can increase the sample size and increase the number of customers that we're placing into the bins, which just by probability, we're going to increase the number of observations going into each one of the bins, which should smooth out some of the spikiness. You're gonna have to remind me of your name. It starts with an S, I think?
Yeah, Sophia.
Sophia. It was gonna be my first choice, but wasn't confident. Yeah, so Sophia's saying let's do one of two things. The first one is just to increase the sample size. So what we're looking at here, I created this figure by taking 800 customers from the larger sample. So we're only looking at 800 versus the entire data set. But what I'm going to do next is actually increase the sample size to the entire data set. So I've increased the sample size, and here you can see these two ages get much closer to each other. So the random noise that we saw in the earlier figure has gone away. Or it's at least shrunk. Like, we haven't gotten rid of it, but we've made it a lot less spiky, simply by allowing ourselves to place more observations into each one of the bins. And then the other thing we could do is change the bin sizes. And this is something Jake mentioned earlier. We can just increase the bin width. So where before we were going from a bin width of 10 years down to 5 years and then down to 1, here we still have some variation that I'd like to get rid of. So what I'm going to do is increase the bins from 1 year to 2 years. And that's going to reduce the noise beyond what we did by increasing the sample size. Okay, so larger bins collect more observations per bin, and so that reduces some of the noise. We're going to talk a lot about random variation, sample size, and noise when we hit part 3. This is just a preview of some of that statistical thinking. Okay, so we can't answer our original question distinguishing between 44 and 45 anymore because we've put those 2 years in the same bin. But what we can do is distinguish between pretty close intervals. So we can distinguish between the 44 to 45 interval and 46 to 47 interval. So we can do that here. And how many of you think this is a good figure? How do you think it's maybe not a good figure? Okay. Anyone want to represent opinions on this? Why is this a good figure? Why is this not a good figure? Yeah.
I don't know, I just think there's so much going on. Like, you can see who has the most and who has the least, but also there's just so much data in front of you that it's just kind of hard to make out what you're looking for.
Yeah, okay, so and you're talking about all of the different bins. Yeah, so very narrow bins. So maybe it's pretty difficult to, it's a pretty noisy figure in that way. Yeah, for sure. What else? Yeah.
I think the advantage of having smaller bins, you can more easily see skewness.
Yeah, so there are these nuanced properties. One of them is skew for the distribution, the empirical distribution of our data. And one of the nice things about being very fine-grained like this, even though it does introduce a lot of visual components of the figure, it does allow us a much more detailed picture of the distribution. Remind me of your name. Darren. And say that probably. Joe. Yeah, very good, somewhat counterbalancing observations. Yeah, Luke.
I was going to say wider bins because the question is what age group, and I feel like there's not really a difference between a 44 and 48-year-old. So you probably want bins that describe the picture and the question that's being asked.
Yeah. Yeah, nice. So one way this figure may not be great for the specific question we're after is that age group is, we generally consider that kind of larger bins than 2 years. Yeah. What else? Yes.
Yeah.
That's right.
The y-axis or the x-axis, or both axes don't have like number labels, so you'd have to base everything along 44, 46.
Yeah. Yep, so I've created a figure that answers a very specific question, which is 44 and 45 versus 46 and 47. But this figure doesn't directly answer, as a couple of people pointed out, doesn't directly answer the question at hand, which is the difference in age groups. And if you were after that question, you should put more horizontal labels. Yeah.
Apart from, I feel like visual criteria, I feel like if you look at it statistically, it seems like a really good data to me.
Yeah.
Because if we look at it from like single year perspectives, it gives us really good information about specific things that we might be looking for. For example,
Yeah.
If we looked at the larger bins, answering a question like how was it different between 44 and 45-year-olds would have been different.
Yeah.
But I feel
Yeah,
like
yeah.
this is more accurate, and also it seems pretty reasonable because this time the 44, 45, 46, all these ages, they seem pretty similar. So it makes sense for it to be this way. So it's pretty accurate to me.
Yeah, this is generally my opinion here too. There are some, like, if I were trying to answer the question at hand, I would add more labels on the horizontal axis. I would maybe take out the red, highlighting the specific year, and then maybe I'd also increase the bin sizes slightly to maybe 5 years. 5 years might be like a nice sweet spot. But if I'm trying to understand the distribution itself, this I think is a pretty good figure. Just maybe more X ticks, and I take out the red. So one of the main conclusions here is there is no universal conclusion, right? Like, you have to be thinking about your specific question, the amount of noise that's in your data set, and then sort of tailor your visualization to match the thing you're trying to do. But some general ideas. We want to reduce the amount of noise. I think noise is not a good thing when you're visualizing your data set. This level of granularity, I think, is a pretty good amount of noise. We've gotten rid of a lot of it. And it gives us pretty good resolution. Any concluding comments here? So let's just summarize. Histograms are a great way of visualizing numerical variables. Another typo, who's putting these slides together? Another typo, just say numerical variables. We generally, almost always we want our bin sizes to be of equal size. Remember that really weird looking histogram from earlier? We don't want different sized bins. And then we want the bins to sort of trade off sort of precision and the statistical noise. So we want to try to reduce as much of the statistical noise as we can while giving us a lot of detail about the distribution itself so that we can see things like skewness. Okay, any questions here? You all want to do this? That's not the rousing enthusiasm I'm looking for. So we're going to run through an exercise. We're going to make histograms in Excel, and then we're going to make them in Python. As always, This is a collaborative room, so if you're running into issues, someone else next to you may be as well. So be helpful when you can. And if you're running into issues, don't hesitate to reach out to the people around you who are potentially able to offer you some help. So the first thing we're going to do is actually, instead of working with the entire data set, what I want to do is look at customers below the income of $40,000 per year. So we have income data, and instead of looking at everyone, which we've already done, let's look at a subset of the population. So what I've done is given you okay, so third issue today, I've included the entire data set here. In Excel, we're going to create the histogram from the entire data set, but then we're going to try to answer the subset question in Python, which will have the subset for the customers under $40,000. So the first thing we're going to do is create a histogram in Excel. So if you go to exercise 1.2 and click on Starbucks profile data, this will download for you the Starbucks profiles. Okay, and then I'm going to, so I've downloaded this data set into my downloads folder. And what I'm going to do is move that over to my desktop. So I have, a class folder, and I have our nice folders in the class folder. I'm just going to create a new one for part 1.2, just to keep things organized. And then I'm going to take Starbucks customer profiles and then just drag this over into the nice folder that we've created. I'm going to stress this every time we do this. Keeping your data set organized will save you a lot of hassle later on. You can see already we have 3 exercises we've done. If we just placed all of our data into the downloads folder, it would be very easy to lose track of what we've done and where we've done it. Okay, so what we're going to do first is just open the CSV file in Excel. And a couple of people came to me about double-clicking on a CSV file and it not opening in Excel. Depending on your operating system, you'll have to change the default app when you open a file. If you're on Mac, it may default to using numbers, which is the default, much worse version of Excel. So you'd have to go into settings and change the default app so that when you double click on it, it will open in Excel. If you don't want to do that, you can right click on the file itself and go to open with, and then in this list, it'll give you different options for which app to open. And you'll be able to click on Excel. And I think Windows has a similar problem, except Windows doesn't force you into using numbers, which is nice. I think it will default to using Excel, but it's been a while since I've used a Windows computer. So once you've opened the data set, you'll have it here. And then you just want to save this as a Excel workbook. So you'll click Save As, either in the banner, or if you don't have a banner, you can go up here to File and then Save As. And then you save it as an Excel workbook, and save it just in the same folder as the original data set. Click Save, and then we are off to the races. All right. Any questions here? Very nice. So the first thing we're going to do is create a histogram of customers by age. So the first thing we're going to do is just select the age column, and we're going to go up to insert. So on the upper bar here, we can click insert. Everyone on board so far? How many of you have a nice file system already set up? Oh, that is not nearly enough people. I pretty much need this from everyone. Set up a nice file system. It will save you a lot of hassle. How many of you have Excel set up as your default app for opening CSV files? Nice, that's a little better. And how many of you have selected column C? Nice. So anyone know what we do next? Let's go up to insert. And then we're going to run over here to our visualizations. And you can see we have this one here, which is, I don't know if you can read that, but it says statistical. If you hover over it, it says statistical. If you click on it, it will bring up the different options here. And the one we're after is histogram. So I'm just going to click on this. And Excel, in this case, is pretty simple. It's just going to create a histogram with automatically created bin sizes on the horizontal axis. And it's going to just bin all of the observations in our data set. And you can see there's a huge number of observations here. In terms of like economic data, this is actually not that big, 14,000. But I think the first time you see a data set like this, it may look big. It's much larger than what we had last time. Okay, so here we have our histogram. Anyone notice a problem? Yeah.
I'm not sure if that's true, but the ages are decimal.
Oh yeah, so yeah, I think the default way Excel shows the x-axis for histograms is pretty bad. These are not, it's a little hard to see here, but this is 18 to 20.5. Weird. It's like a weird setup. And then it's pretty difficult to read this. You have to like tilt your head. So we're going to do a little bit better, particularly in Python. So maybe the bin sizes, the bin widths are a little bit weird. What else? Oh, remind me of your name?
Sabi.
Sabi. Yeah, Ruby. Yeah, so there's a lot of noise here. And you can see kind of why that's true. The bins are about 2.5 wide. So maybe we want to increase the bin sizes. What else? Well, I'm going to change the title. So you double click on the chart title, and then you can select the text. I'm going to say Starbucks customers by age group. Okay. Anyone know how we change the bin sizes? Sometimes Excel is simple. Sometimes it's very complicated. Here it's pretty simple. Just double click on the bins themselves, and it will bring up some options for you. So here we have auto bins. And what I want to do is select bin width. So I just want bins of 5 years. So I'm going to select bin width and then set it equal to 5 and hit enter. We see some options here. There's an overflow bin, the underflow bin. If we set this to 15, that's not doing anything. You can also change number of bins if you like, but there's a lot you can do here. If I wanted to start this at 20 instead of 18, I'm sure there's a way to do it, but I don't work with Excel enough to really be super proficient with how to change the starting bin. Some of you may be more proficient with setting bin widths and intervals and all of those things. These things are much easier to do in Python. But this is generally how you would create a figure like this in Excel. These are the basics. You can do this pretty easily. Any questions here? And I think Excel figures generally look pretty good. Like, I think this is a pretty good figure. It's not as good as the ones I have in the slides, I think, except for that first one, the terrible one. But this is, I think, pretty good. Some other things you might want to do, you could get rid of the horizontal lines if you like. It makes it a little bit harder to find the actual numbers, but I think it makes it less cluttered. But that's a personal preference. Then the last thing we want to do, and particularly for the purpose of submitting work to Gradescope, or if you're including your figures in slides, or any sort of any external purpose outside of Excel, one thing we often do is save these figures as images. Anyone know how to do that? Okay, so this is pretty straightforward here as well. I'm just going to right-click on the figure and drop down. There's an option that says Save as Picture. I would recommend using a naming convention for your save for your figures when you save them. So I'm going to put the figure in the same folder as the data set. And we're in part 1.2. So I'm going to call this exercise. And it's difficult to save with dots. You might be able to, but I like to use underscores just to keep things clean. Exercise 1 underscore 2, so like 1.2. And then this is the first figure we're saving from this exercise. So I'm going to call it exercise underscore 1 underscore 2 underscore 1. So it's 1.2 exercise figure 1. But you can save this however you like. This is just the way I would do it. And when I hit save, then I'm going to have this figure as an image file in my folder. And I can open it. Oh, whoops. Where'd that come from? Maybe we'll move this over a little bit. So now you can see. So now you can see a nice picture of customers by age group. All right. Any questions here? And then this is something you can submit to Gradescope, or you can put in your slides when you're presenting your final project at the end of the semester. It's a really powerful tool. All right. Any questions? Okay, a little distracting. So let's save this. We're going to do a very similar thing in Python, except it's going to be a little bit quicker. And we're going to have much more control over the bins. So what you can do is go to economic data analysis, and then click on the notebook, which will bring up Google Colab. And you can just do all your imports, run the beginning. And then we're going to look at specifically customers at or below $40,000 of income. So we'll run customers. And we can just print the data set here and just check that it looks the way we expect it to. Okay. All right, how many of you have opened this data set and have loaded the data set in Colab? Hands up. Okay, and the rest of you are getting started? Is that a question? All right. So, I've included code in my slides. I do this so that you don't have to guess. When I post the slides, I'll often post a PDF of the slides if you want to print them out. But I also have interactive slides, which will just open in the browser, which allows you to go up here and copy the code. So I'm just going to click copy, and I'm going to run over to this cell and enter this code. And I want to talk through some of the bits about this. I'm going to start by getting rid of the bins. So this is just a basic histogram. We just have Seaborn creating a histogram, what Seaborn calls a hist plot. We tell it to use the dataset customers. And then on the horizontal axis, we're asking it to bin on ages. So if I run this, I get a histogram that looks like this. You can see the bins are fine, but they aren't in 5-year intervals. How many of you have this figure? If you don't have this figure, maybe just check with someone next to you. Any questions at this point? So I've given a little bit of extra code here. And I just want to talk through what this range is doing. Python has a really easy way of creating lists of numbers. And what I want for my figure is to have bins of width 5 starting at age 20. So I want age 20, and then I'm going to have it go all the way up to age 100. And I want intervals of 5. So if I run this, this is going to give me a nice list with that structure. Okay, that's not a nice list. This range is just giving me a list of 20, 25, all the way up to 95. And this is really nice because I don't have to write out all the bins. I can just say, create bins from this list. And then if I want Seaborn to make a histogram using those bins, I just have to give it another option. You may start writing bins and then have Gemini predict what you're about to write. But I'm just going to write this in for myself. So I'm creating bins with 5-year intervals, starting at the number that I want, which is 20. And when I run this, I have my nice bins how I would expect them. So we have 20 to 25, 25 to 30, 30 to 35, and so on. Any questions here? Can I get an honest poll? How many of you feel a little bit intimidated by this code? A lot of people. Look around. Hold your hands high and look around. You're in good company. These kinds of things will start to feel more familiar. We're in like week 2. The writing of the hist plot will become much more familiar. The way we interact with these kinds of options in histograms will also become more familiar. But you're in week 2 and like day 3 of doing this, so feeling a little bit nervous about this is very reasonable. Okay, but you can probably reproduce this, right? Like you can recreate these figures. Okay. So nice. So we have a nice histogram showing the distribution of ages. Someone contrast this with our earlier figure, the one we created in Excel. How does it look different? How does this look different? Yeah, Alexis.
It's a lot more concentrated at the younger end since we're looking at a lower income.
Okay. So yeah, generally, the younger you are, the lower your income, just less established in your career. What else? Yes. Say that again.
There's no title.
There's no title. Yeah, so we can fix that. What else? Yeah, Ruby.
It's not like
Yeah, so this one is a little bit more concentrated in the middle of ages. I wouldn't say this is normally distributed, but it has that kind of like bell general shape to it. Yes. Yeah, what else? Chase?
I'd say this new one's like skewed to the right.
Okay. Yeah, so there's like a concentration around lower ages, and you don't see a lot of Starbucks customers under $40,000 of income that are above 70, which is pretty interesting. Yeah. Another thing you might notice is that it's maybe a little noisier. There are more jagged bars, especially around these upper ages. There's a lot more variability between age groups. And the reason is because there are fewer people in the $40,000 income group and below than in the entire data set. The entire data set actually has more customers, simply because we have more age groups. So the second data set is actually a subset of our first one with less data. So there's more noise. All right. So another thing we might want to do is save this figure. And I've included some code to do that. So I'm just going to copy this and then jump back over to the cell here. And what I'm going to do is just have matplotlib save this figure. So I'm telling it exactly what to do. And I'm going to call this exercise 1.2 figure. Let's call this figure 2. And when I run this, it will save this as a figure in Google Drive. At least it should. Are you seeing the figure in your folder? No. Huh. So the other way we can save this, that should save. I'm not sure why it's not. I'll post an announcement about how to do that. The other thing you can do is just save the image to your computer. So this is the way you'll probably do this for your homework. And then, so for me, I'm going to save it to our our folder, and maybe we'll call this exercise 122.png. PNG is just a standard file format, standard image format. So I just right-clicked, and then it gave me the option to save it. And then you'll see it here. Okay. And then a bunch of other things you can do. I think this is a really nice figure, but you should give it a title. So you can ask Gemini, actually, give this a title, and it will give you a recommendation. And then you can change this if you like. So Starbucks customers by age. And then run this. And then we'll save this. And we can just rewrite over this. And then you can just upload this to Gradescope. Any questions here? So these are some new steps. You're going to become familiar with how to work with these steps as we go through the semester. A month from now, this will feel like something you could do in your sleep. These kinds of things don't come naturally to anyone. The way they feel familiar is by doing them over and over again. And so in the next couple of homeworks, 1.1 and 1.2, I think I ask you to do it maybe 4 or 5 times. So just get some practice, and you'll become familiar with this. What's that doing there? Okay. Have I told you I just had a baby? All right, so this is one kind of summary of a numerical variable, but there are others. I'm going to show you probably the second one that you should go to most common. How many of you have heard of a box plot? Yeah, nice. Very common. If you haven't, I'm about to show you what they look like and how to read them. So another kind of data set we could be looking at is data from coffee importing countries on coffee consumption per capita. So per capita is just a fancy way of saying, on average, how much is each person in the country consuming? And so we can see I have this nice data set here on coffee importing countries and how much they're consuming per capita in 1999. And we have a distribution here. So a lot of countries are consuming a lot of coffee per capita. So this is in kilograms, which is the raw weight of the coffee itself. And some countries are not consuming a lot. But if I were to ask you something, so this is a nice way of understanding a distribution itself, to get a sense of like the range and the frequency by the horizontal axis. But let's say I wanted to ask you a question about like an average. Like how much on average are these countries consuming per capita? What's the average coffee consumption per capita by these countries? Anyone know what that is? The answer is no. No, you do not. This doesn't show you that information. I mean, you could probably guess that it would be maybe around here or here, but it's pretty difficult to know. There's a lot of low coffee consuming countries, and then a couple that are very high coffee consuming. It's really difficult to see the exact values. And we also don't know exactly which countries are consuming which. So if I were to ask you this different kind of question, which countries drank the most coffee in this year, you actually don't even know what that value is. Someone tell me. I mean, now you know you can't answer this question, but how much is the largest coffee consuming country consuming? Well, we don't know because we put the values in bins. We know the range. We know there is a coffee consuming country that's consuming somewhere between 11 and 12 kilograms, but we don't know what that actual number is. And the reason is because we put our values in bins. I have a better way with a box plot. And it gives us a lot of other important statistical values. So we're going to talk through all the details here, but this is the same figure, but with a box plot. It's the same distribution, coffee consuming countries, coffee importing countries, and their coffee consumption per capita in 2009. And this is what the box plot gives us. In addition to a box plot, and we're going to talk through all the details here, one thing I like to do in addition to a box plot is actually see the exact values. So with a box plot, we're also going to use what's called a strip plot, which gives us the exact values, almost like a scatter plot. So box plots and strip plots, I think, are a really nice combination, which gives us underlying statistical measures, which allows us to answer questions about things like the average. But it also allows us to see exact values because we're actually plotting the exact data points on the box itself. I'm going to show you how to make these things in 2 lines of code. So if I were to ask you about coffee countries that are consuming the most coffee, you could tell me at least give an approximate number here. I don't have like great horizontal ticks here, but you could see it's like a little bit over 11 kilograms per capita. Okay, and then you could also answer questions about the averages. So we have each point representing coffee consumption on the horizontal axis, and then I've given it a little bit of vertical jitter just so the data points don't sit directly on top of each other. This is a technical term, jitter, and it comes default with a strip plot. So I'll show you how to do that. All right, so what a box plot does for us is give us quartiles. So we have these statistical measures. And I'm going to talk you through what each one of these things represents. Probably no one in this room knows what a minimum is. No, you probably all know what a minimum is, right? It's the smallest value. And then the median is just the value. You've all taken a statistics class. You know what the median is. It's the middle point, where 50% of the data is below that value. Q1 is the first quartile, which is essentially just halfway between the minimum and the median. So it's 25% of the data is below it, and then 75% is above it. So that's Q1. Just like minimum, no one knows what maximum is. So maximum is the largest value. So we have the median and then the maximum, and then Q3 is just halfway between those two. So we have 25% of the data living above Q3, between Q3 and the maximum. So this breaks our data into 4 parts. We have the middle 50, which is given to us by the box, and then we have the lower 25 by the lower whisker, and then the upper 25 by the upper whisker. So this is how to read a box plot, at least with no outliers. And what this does for us is gives us not the box plot with the strip plot gives us not just the statistical measures, but also it gives us the exact data points. So this gives us much more information than either on their own. So I can tell you that there's actually a lot of countries that are clustered right around the median. You can see it's 4 right there. and then there's one country that has a much larger coffee consumption. Yeah, maybe 1 kilogram more than the closest one. Okay. How many of you like this kind of visualization? Hands up. How many of you don't? Why do you like it? Yes.
I feel like the pretty obvious answer would be that in non-figure you get a lot of stuff like minimum, the Q1, Q3, median, and max, and also you get like an idea of the average.
Yeah.
And also like to take it a step further, usually on appliers as well that you
Yeah.
can see with the box plot. So I think it's pretty accurate and easy to like comprehend visually.
Yeah. The thing I like about this is it gives you information about the summary statistics, but it also gives you the data directly. And I think that's really powerful. Someone who doesn't like this, why don't you like it? Maybe because it's a little bit harder to read. There's a lot going on, so it can potentially be a little bit distracting. And you have to know something about what a box plot is doing. I think adding the strip plot makes it a little bit easier to intuit what the box plot is telling you. But even still, you have to know a little bit about a box plot to be able to interpret it. But generally, I think these are pretty good figures. Another thing it allows you to do is just make visual comparisons. So let's take maybe 10 seconds here. I want you to answer this question. Which countries consumed more than 8 kilograms per capita? Or how many countries consumed more than 8 kilograms per capita? So I'm looking for a number. 10 seconds, and then tell your neighbor. Is that an answer? What is it? 6. So you can see 6 here. 1, 2, 3, 4, 5, 6. Who made this figure? Okay. Send a letter to the provost. Terrible slides. Day 4. All right. So we can, make, subsets of the data. It's pretty easy to make those kinds of comparisons, simply because we have the horizontal axis and then the strip plot over top of the box plot showing us the exact values. And then we can also do these kinds of things, like which country, which specific data point has the maximum. Well, this is almost too simple for me to ask you to try to answer, right? It's just you look for the largest one and then you select it. This one turns out to be Finland in 1999. Has anyone been to Finland? Nice, respect. Did you drink coffee in Finland? Okay, nope. So we can just run through a couple of quartiles here. The minimum, we just select that, which in this case is Russia, which is a little surprising. Maybe given the geopolitical context in 1999, maybe they just didn't have a lot of access to it. What about the median? Well, in this case, we just find the middle point, the one that's sitting directly over top of the median line. And here that's a little bit hard to see, but it turns out it's us. Directly median in 1999, which we're about to see if we have time. We don't have time. We'll pick that. We'll pick up the next example next time. But that's about to change. And then we can find which country consumes more than exactly 25% of countries. So I want you to try to figure out where this is visually and then tell someone how to find it. Five seconds.
to it past the first quartile. The left end of the box.
Oh, yeah, this one.
All right, someone tell me how we find it. Hannah. So the first quartile, yeah, so Q1. So it's going to be Slovakia. We find it because exactly 25% of the data is below it, which is what the Q1 tells us. All right, Slovakia. Anyone been to Slovakia? Anyone been to the US? I've had coffee in the US. In fact, 4 hours ago. And then we can do the same thing for the 70th percentile. So this is Q3. And it turns out it's the Netherlands. You can see there's like a huge disparity between the Netherlands and what was that, Finland? Okay, so here's our 5 quartiles. And we can do this, I mean, it's a little bit hard to do it without seeing the data set, but these are things we can do. We can find actual numbers and where the quartiles land. And this is not something that's particularly easy to do in a histogram. So we have more information displayed to us in a box plot with strip plot. Okay, so nice. So box plots, just as a summary, make it easy to see the quartiles. Strip plots then on top of that give us the underlying distribution, just the raw data, which is nice to see sometimes. So for your purpose, that may be the way to go. And then from there, it makes it easy to select the subsets just visually. Any questions here? Any major disagreements? Quibbles? Quandaries? Concerns of quackery? All right. So I'm gonna get this set up for us in Excel. In Python really quickly. We'll pick this up in more detail next time, but we can make really nice box plots and strip plots. I'm going to show you how to do this in Excel next time, but we can do this easily in Python in 2 minutes here. So I'm just going to load the data set. I've already given this cell to you just to load it. And then we can take a look at what's in the data set. So we have coffee, print this out. And so you can see we have the country code and then the coffee consumption per capita in 2019. So you'll remember in the slides, we were looking at the year 2000, nope, third time, 1999. We're going to look 20 years later and perform the same exercise. And what we might want to do is just create a box plot. So just from scratch here, I have SNS, and then I want a box plot. Somehow Gemini expects me to write a box plot. This is frankly a little creepy. How does it know I want a box plot? Well, maybe not so creepy. I've given it some context for what I'm trying to do. And so Gemini, in a lot of these cases, will be able to infer the context of what you're aiming for. And you can even write box plot just directly in the cell. And it can also read your data set. So I have sns.boxplot and then coffee. It doesn't actually get this right. So I'm just going to write sns.boxplot. I don't need to write in data equals. I can just write in the data set. So I'm just going to write coffee. And then I want the horizontal axis, just like in the slides. I want the horizontal axis to represent the coffee consumption per capita. So I'm going to write x, because it's our horizontal axis, is equal to, and because I have the data set listed out here, I can easily see what I'm doing. So I have coffee in 2019. And that's it. I'm just going to run this, and it will give us this figure. Now, one thing to notice here is we have, by default, a box plot, both in Python and in Excel, will give you outliers like this. But when I'm displaying a box plot, I actually generally don't want outliers. One thing we can do is write in maybe no outliers. So we could show flyers false. But the way to do this, and I have this in the slides, is to include this option here, which is to have the whiskers go from 0 to 100%. So I'm just going to add this in. And I think when people start learning code, sometimes I think what feels intimidating is where do all these things come from, all these different options? And you just have to, there's not a good answer. It's just, I don't remember what they are, so when I go to write a box plot, I have to look it up. That's just the way things go. So I'm going to write whis is equal to 0 to 100, and then we run that. And that will create a this figure. The last thing, can I have you for 20 seconds? I'm going to write a strip plot, and I'm going to show you that it's not any more complicated. So this is sns.stripplot coffee, and then again, I want the horizontal axis to be coffee 2019, and then I run that, and then I save the figure. I will see you all on Tuesday.
One of the questions asked for the second most frequent excitement level for the class.
Yeah.
But there were two values that were tied with first.
Okay.
So do you want the one that's actually third, or what would you want?
So yeah, just give me the time.
The tie, okay.
Hey.
I just
Nice.
so